We are handling a problem of NEET of 2007 that's from one-dimensional motion. Looks like a very big problem, but it's actually very simple. Let's try to understand. It is given that Preeti reached the metro station and found that the escalator is not working. What do you mean by escalator is not working? She has to walk on her own. She walked up a stationary escalator in a time t1. So what's the meaning of this? Let's have a look at here. Let's stop here and have a look at this, right? She is traveling a certain distance. While she is traveling a certain distance, she is walking on her own when the escalator is not working, right? When escalator is not working, she covers a distance, yes, with a velocity unknown v1, but it is given that the time is t1, right? Now let's have a second part of the problem. On other days, if she remains stationary on a moving escalator, that means on this day escalator is working. Escalator takes up her in a time t2. Now, second time she is not keeping the effort, but the escalator is doing its job, right? When escalator is working, earlier it's not working, but today it is working. Still, she has to go for the same destination, so her displacement is same, but this time it goes with a different velocity. And time is also different. It is given that the time is t2. Now he is asking a third case. What's the third case is? The time taken by her to walk up on the moving escalator will be. Now, obviously she is in a hurry. So she is walking on the escalator and the escalator is also moving upward. So both the cases, right? When she is walking as well as escalator is moving up. So both of them are working, right? Escalator is moving up. So in the first case, if I have to write time which is given for you, I can write S by V1. Second case, if I have to write time t2 as S by V2. The third case, time t, we have to find out as still she is covering the same distance. Her destination is same on each day. As both of them are moving, in this case, it is obvious that she will move to the destination quickly. So the numerator is same in all these cases. If the t she moves quickly means this t is less. T is less means this denominator means more. That means both the velocities add up and that takes less time for her to travel. So this t is how much he is asking to find out. Yes, in the place of v1 from here I can write v1 as s by t1. From here I can write v2 as s by t2. Let us substitute that values. S by t1 plus s by t2. S in the numerator. S can be taken in the denominator in both the terms. 1 by t1 plus 1 by t2. So s and s can be cancelled. So this will be, see, be careful, it is in denominator. 1 by t1 t2 t1 plus t2, that is in denominator of denominator. So if I have to reverse to get the final value, I have to reverse that. S is how much? t1 t2 by t1 plus t2. Where is that option? Yeah, here is that option. That is the right answer, right? That's how we get the answer to this problem. And to solve this problem, though the problem looks like a big problem, we have used a very simple concept. What is a very simple formula that we have used? It's not even a formula. It's a very simple thing that we have used. This displacement is equal to velocity into time. From where you got that? Very definition of the velocity is rate of change of displacement. Rate of change means by time. So this is not a big problem. It is very definition of velocity as rate of change of displacement that you might have learned in probably 8th class or 9th class itself. You need not be in +1 +2 itself to solve this problem. That is that simple. That's it. Thank you for watching.